In the last video, we learned what a radian was. We learned about some common measurements that you will see all the time when moving on to pre-calculus and dealing with angles on a larger scale. Before we get started with our conversions, because a logical thing to be able to do is, well, okay, we have this new way of measuring angles. How can I go back and forth? How can I relate degrees to radians? I want to show you two examples here relating to something you did probably in like freshman year, algebra 1, middle school, something like that, where you learned how to convert units. I know you guys can do these problems, but I want to show you how I think about these because it really relates well to how you'll do it with radians. So if I have 20 inches and I want to turn that into feet, I'm starting out with 20 inches. And the way I think about this problem right here, I know 12 inches is the same thing as 1 foot. Those are equivalents. So what I'm going to do right here, if I multiply by 1 foot over 12 inches, this fraction right here, these two pieces, are the same thing. The top and bottom are the same. 1 foot is the same thing as 12 inches. So what I'm really doing right here is multiplying by 1. When I do this, multiplying by that yellow circle, which equals 1, I'm not changing my answer at all. And the reason this is a good thing, why would I want to multiply by 1 like that? I have inches on the top, inches on the bottom. Those will cancel out. My units go away, so all I'm left with in terms of units is my new guy over here in feet. So when you do that, you end up with 20 over 12 feet, which you can either simplify or you can turn into a decimal. Either way is okay. But you end up with either 1 2/3 feet, or if you wanted to, 1.6 repeating feet. So multiplying by clever form 1 was actually a good idea there because it helped cancel out my units. On my second problem, I'm in 5.5 pounds. And I know that 1 pound is the same thing as 16 ounces. In this one, my pounds are on the top. So what I want to do, I want to multiply by 1, so I'm going to take these two pieces here and put them in a fraction. But I want to make sure my pounds are in the bottom. That way, they will cancel out. So I'm left with this right here. I need to be able to do, basically, multiply straight across. Because when I multiply these, my pounds are going to cancel. And my new unit is going to be in ounces. So if I actually multiply that out, it looks like we end up with 88 ounces. That's how you convert units. And it seems like, yeah, I know how to do that already. Why are you wasting my time with that? But if you keep this in mind, converting between radians and degrees is really, really not bad. So let's say I had an angle of 60 degrees. And I wanted to convert to radians. So if I have a 60-degree angle, I want to turn that into something in radians. Well, I know, just like on the last slide, I remember that pi radians is the same thing as 180 degrees. They're pretty similar, like, I mean, it's a pretty simple, I could have done 360 and 2 pi, it doesn't really matter, but this one, at least there's just a plain old pi there and 180 degrees. Those are the same thing. So what I'm going to do right here, you can think about this degree symbol kind of like your unit on the problem. I want to cancel out my degrees. And it is important, by the way, that you start writing degree symbols if you don't already, because otherwise, if you just see a plain number, like if I just saw a 5, by default, if there's no unit on it, you assume it's radians, actually. This would be 5 radians right here. If I wanted 5 degrees, I would need to put that mark. But anyway, we're kind of treating that like a unit right there. So I want my degrees on the bottom, so they're basically going to cancel. You can think about it like that. Units are going to cancel. So I need my pi for radians on the top. And a unit on a radian, again, you don't have to put one there. If you don't see a unit, it's assumed to be radians. And if you see a pi in a problem, there's a really good chance it's a radian. But anyway, if you actually multiply across, you get 60 pi over 180, which if you do the math and simplify, you get 1/3 pi, which you can also write as pi over 3. So this is the same thing as pi over 3 radians. And to prove a point right here, this is actually kind of an important thing for those of you especially who are going to be taking the ACT and if you're going to use a graphing calculator on it. When you guys were in geometry, you would do things like SOHCAHTOA, you would do something maybe like sine of 60, just like that. And you see here, we got a really strange answer. If you go to the button on your calculator that says Mode, very top left, next to the blue button, right now, the third choice down, you see the calculator by default is in radians. So if you wanted to do SOHCAHTOA, you just basically need to make sure that degree is selected again instead, like what you see right here. If you have your degree highlighted and you do sine 60, you'll figure out what that actually equals. Now to prove a point though, that's sine 60 in degrees. We just found out that's the same thing as pi over 3 radians. So what I'm going to do right now, go back, I'm going to actually change my calculator into radians. So now I'm in radians, and I'm going to do sine pi over 3. And we're going to see what that ends up equaling right here. If you do sine of pi over 3, in radians, if you're in the mode, it's the same thing. They're equivalent measures for the same angle. So that's something to be very cautious of. Make sure you are in the right mode when you're doing these problems. Okay, let's do another example. Let's say for my angle, we had negative 150 degrees. So we're dealing with a negative angle measure here. Again, I'm going to multiply by a clever form of 1 so my units cancel. Want that 180 degrees in the bottom, want that pi up top. And when you multiply that out, you're going to end up with negative 5 pi over 6 radians. You can check the math on your own to make sure, but you reduce your fraction, that's what you should end up with. I'm going to do one more problem in this video. Let's say we had 103 degrees, and we want to turn that into radians. When you set this one up and you multiply by pi over 180 degrees, just like always, your answer is not going to be nice. You're not going to get a nice fraction that reduces well. When this is the case, you will usually write your answer just as a plain old decimal. No more pi even in your answer. So if you do 103 times pi and then divide by 180, you're going to get 1.798 for your answer. So to recap that again, if you have a nice answer where it's like, oh, on the last example, we had 60 degrees, that reduced really nicely to just 1/3 when you did that. You should leave the pi in the problem and you should just make the nice fraction. If it's an ugly answer, you can just multiply the pi into the problem and you get a decimal answer. But that is how you convert from degrees to radians. Let me recap that for the final thing right here, just so you have the notes. To go from degrees to radians, multiply by pi over 180. That's kind of our conversion factor to do the problem.